Hello, this is an introduction to cloud computing. My name is Bunn. I'm a principal computational scientist at Caltech, part of the Center for Data-Driven Discovery. In this talk, I'm going to cover cloud computing, but I'm going to start with a little bit of history, what came before cloud computing. Distributed computing. So this is the idea that where you run an application on one or more computers that are connected in a network. The computers are autonomous and they're possibly heterogeneous, so there may be several different types of computer involved in this computation. The target problem is then subdivided into separate tasks which you run on these different resources in the network. The computers communicate via messages, and you can compare this method with parallel computing where there's not really a network so much as there's a tightly coupled set of computers which are working on the problem, connected over some network fabric or some messaging fabric. Grid computing is relatively recent. It's distributed computing with authentication. So this means use of certificates and that sort of thing. It's supported by, for example, the Globus toolkit. There's no central control. The concept of virtual organizations is important because there you're able to partition the resources according to who has access and what organization they belong to. And this grid computing, it's typically used in research and academic communities, not so much in the commercial area. It's a little bit long in the tooth, and it's certainly a little bit hard to use. So we come to cloud computing, which is not so long in the tooth and supposedly considerably easier to use. Cloud in this context is a metaphor for the network. We have an abstract view of physical infrastructure, so the computers and the networks that are involved, and you access the resources in the cloud as services. So the resources are shared transparently, they're virtualized. That means that you get access to virtual machines, so these aren't real machines, they're parts of real machines running in memory address space. You get some inherent scalability with this approach because it means that the machines in the cloud system can be dynamically allocated according to the load. You typically get some guarantees of service, so you get some guarantee about how much CPU time, how much memory, and so forth, how much disk storage you can get access to. The systems are mainly commercial, and you're probably familiar already with some of the ones from Amazon and Google and so on. And typically they're pay as you go, so you pay for how much you use, and this makes them rather attractive if you're on a limited budget. And they are rather simple to use, as we'll see in a moment. Now, cloud services can be separated into some different categories. One of these categories is software as a service, otherwise known as SaaS. For example, Gmail is a SaaS service. This is where you have a piece of software and it's provided to you as a service that you can use. Then you have platform as a service. Google App Engine is a platform which you can use as a service. Microsoft SQL Services are another platform which you can use as a service. And this requires some rather more work to actually use them, and we'll go into that in a little bit later. And then there's infrastructure as a service, IaaS, Amazon EC2, and we'll go through how to set up an account on Amazon EC2 in just a moment. So briefly then, SaaS, the user just uses the service like Gmail. PaaS, the service appears as a potentially infinitely large computer running an unknown operating system that you don't care about. And IaaS, it's where the service hardware is abstracted away completely. Now let's look at a very practical way you can get started now with using cloud services, and in particular one of the most popular is the Amazon EC2. This is the Elastic Compute Cloud. It's a web service that provides resizable compute capacity in the cloud, and it's supposed to be easy for developers to use. You can try it for free, so they provide you with up to 750 hours of what's called a T2 micro instance per month for a year. And a T2 micro instance is quite a large enough instance or quite a large enough virtual machine for you to do some interesting computation with. So let's have a look at how you might set up to use EC2. Well, the first thing to do is to create an account, and you can go to this website that's mentioned on the slide here, and you can click on the button saying try AWS for free. You can create yourself a username using your email address. You'll need to enter a credit card number. I actually used a gift card while I was preparing these slides with a few dollars on it. Not because I don't trust Amazon with my real credit card, but because I didn't want to take any more risk than that. At this point, Amazon will call your cell phone number, which of course you've provided as part of a registration process, and you enter a PIN which they provide you, and then you sign up for the basic free support plan. So once you've done that, you're presented with a screen. You can see the top left here. There's sometimes a delay before you can actually use the management console of AWS. Once you have waited that delay, then you can see the various services that are provided on the bottom right-hand screen image. And as you can see, because this is America, there's lots and lots of possible choices. We're actually going to choose the one at the top left, the EC2 service, the Elastic Compute Cloud Service. So you choose that. And then you can launch one of those instances. So this means that you're actually going to create an instance for you to use. Now, when you do that, you are allowed to select between various different machine images. Machine images means just as if you had a desktop system or a laptop, you can choose what type of operating system and how the machine is actually configured. Because we're trying to do things at the moment at very little cost, we can restrict the choice of the machine image types to a free tier, which means it won't cost anything at all. And I've just arbitrarily really picked this one at the top of the list because it has Python, and that's what I like to program in, so I'm going to pick that one. But you may well pick one of the other possible machine images there. After you've done that, then you choose the instance type, and as I said before, we're going to be using this T2 micro, and you can look at the specifications for the T2 micro instance type. It may be that for some reason you're going to need to run an application that needs a lot of memory, in which case maybe the T2 micro isn't suitable for your needs, but in this case we're going to pick the T2 micro instance. Once we've picked that, we're just going to launch the instance. So we launch the instance by clicking on the relevant button in the top right, in the bottom right-hand corner. Before we can do that, we need to create a key pair. And we're going to need to create this key pair so that for the machine instance that's created for us, we're able to log into it remotely, access it remotely, and do things like move data files into the machine instance which we want to run our processing on. So you save this key pair file, which is a file type of PEM, on your local machine. It's really just a text file. If you look inside it, you'll just see a load of gobbledygook in there, which is actually assigned code which identifies you and identifies your access to this particular instance. So once you've done that, once you've saved that PEM file on your local machine somewhere you remember, you can then launch your instance. And here we are. You've seen here that the instance has been launched, and you get a name for the instance, and you can see various details in the bottom little section that I've extracted that shows you things like where the instance is and so forth. Okay, so that's all fine and dandy. We now have our instance launched. What are we going to do with it? Well, the first thing we need to find is the public IP address, the DNS name of the instance. So this is a virtual machine, but it actually has a real IP address on the network, and using that IP address we can log into it. And the way we do that is shown in this little code extract at the bottom, which is a console on a Windows machine, and here I'm using SSH with the key pair file, which I downloaded earlier, so that's the Julian Amazon EC2 keypair.pem file, and then I'm specifying the IP address of the instance, prepended with the username which has been given to me by Amazon, which is EC2-user. And if you SSH to a machine, then you'll find that you can then log in to that machine, and it appears once you've logged in just like any other Linux machine. And for example, you can then at the command prompt do a simple little test where you create a little Python file and then you can run it. You might at this point, having satisfied yourself that Python runs correctly, you might then want to update the instance. So you might want to update the software on this particular instance by using one of the Linux tools for updating software. And you then might want to copy some of your data files into this instance from your local machine or from somewhere else so you can run your application on it. So that's a very quick and rather pedagogical introduction to how to set up an EC2 instance and start working with it. And probably fairly rapidly you'll discover that the instance that you've got isn't quite enough for your needs, and you're going to then have to start looking at creating other types of instance, or maybe even, God forbid, paying Amazon for a very large instance. Now I want to say just a quick couple of words about the Google App Engine, which is quite a different type of cloud computing environment. With Google App Engine, you don't log into instances. Google provides a whole bunch of already pre-configured instances which are running their software called Google App Engine and Google Cloud Services. You can have a web application which runs on Google's infrastructure using this system. So you upload your web application and then it can serve users. And you can write your application in one of these given languages, Java, JavaScript, Ruby, or Python. And what you get on the Google App Engine is persistent storage, and you get very good automatic scaling and load balancing that they provide. Because their resources are so enormous and so widely distributed, you get extremely good scaling behavior for this if your load goes up very rapidly, for example. You get other little bonuses like authentication. You get things called task queues, which allow you to submit jobs to be run outside of web requests. You can also have things like cron jobs running in the App Engine, this sort of thing. So they measure resources in terms of gigabytes and CPU hours. And again, there's a free tier that you can use on Google App Engine. You can sign up for the free tier, and that will allow you to really run quite a serious web application, maybe with not too many requests. So if you've got an application which is supposed to service tens or hundreds of requests per second, then you're probably going to end up having to pay for that. But for something which services periodic requests from browsers, for example, the free tier tends to be sufficient for that. The other very nice thing about the App Engine is the data store. So this is a distributed storage system which has its own query engine with a syntax really rather like SQL, but it's not quite like it, so sometimes that can trip you up. And it has transactions. It has objects which you can place into the data store, and then you can run queries and indexes and all that sort of thing. There isn't any particular schema associated with it, so programmatically you create your own schema. There is no restriction on that. So in the App Engine there are various services and tasks that are supported. So there's URL fetch, which which is allowed. So, for example, if you want to have mechanisms which allow the user to download or upload files to and from the App Engine, that's very nicely supported. There's mail, which of course you can use to notify users when things have happened or when things haven't happened. There's a feature called Memcache, which is an in-memory set of key-value pairs, which is extremely convenient. So this is good for fast lookup of values that may be part of a computation, values which you don't need to keep forever, in which case you'd use the data store, but values which you'd like to get access to very rapidly. And then there are other features which you'd expect people like Google to provide, like image manipulation. And then you can obviously create your own applications in code. And that's where the challenge comes in. That's where it gets a little bit more tough than, say, Amazon EC2. Alternatives to some of these, there's things called AppScale from UC Santa Barbara. It's an open source implementation of the App Engine. And then this executes in Eucalyptus, IAS, and it's compatible with Amazon EC2. And then you can use, obviously, your own private cloud if you want to. If you don't want to use Google's infrastructure or Amazon's infrastructure, then you can always create your own private cloud, and that's what a lot of universities, for example, are tending to do these days for their research needs. And that's the end of this short introduction to cloud computing. Thanks very much for paying attention.